Let us start with Amazon Lambda service. AWS Lambda is a serverless, event-driven compute service that lets you run code for virtually any type of application or backend service without provisioning or managing servers. You can trigger Lambda from over 200 AWS services and software as a service (SaaS) applications, and only pay for what you use. Let's see some popular use cases in AWS Lambda. 1. File processing. Use Amazon S3 to trigger AWS Lambda data processing in real time after an upload, or connect to an existing Amazon EFS file system to enable massively parallel shared access for large-scale file processing. 2. Stream processing. Use AWS Lambda and Amazon Kinesis to process real-time streaming data for application activity tracking, transaction order processing, clickstream analysis, data cleansing, log filtering, indexing, social media analysis, IoT device data telemetry, and metering. Three. Web application. Combine AWS Lambda with other AWS services to build powerful web applications that automatically scale up and down and run in a highly available configuration across multiple data centers. 4. Mobile backends. Build backends using AWS Lambda and Amazon API Gateway to authenticate and process API requests. Use AWS Amplify to easily integrate your backend with your iOS, Android, web, and React Native frontends. AWS Lambda is a serverless compute service that permits you to run code without controlling or provisioning servers. Lambda uses highly available, elastic infrastructure to run your code. It carries out compute resources administration tasks, such as automatic scaling and capacity provisioning, operating system and server maintenance. Lambda can run code for almost any form of backend or application service. In a serverless model, code needs to be organized into functions. Lambda only runs your functions when necessary. It scales automatically, varying from several requests a day through to thousands a second. You only pay for the compute time you use, you won't be charged when code is not run. At a high level, applications that use AWS Lambda are built on the serverless architecture pattern, which enables an event-driven architecture. An event-driven architecture uses events to trigger and communicate between two services. An event can be a change in state, an update to a record, or a new data record. An event-driven architecture has three main components: event producers, event routers, and event consumers. An event producer generates the event and publishes it to the router. The router filters, processes, and sends the event to the consumer for further processing. Producers and consumers are fully decoupled and unaware of each other. Event producer is a starting point for an event-driven architecture, and is also known as an event source in AWS Lambda architecture. An event source is going to publish the event to a Lambda function and can be of various types. A REST API method call. A CloudWatch event triggering a Lambda function with the change in the state of an AWS resource, example, invoking a Lambda function to log the change in the state of the EC2 instance. A new record in a DynamoDB table stream. Lambda polls the stream, and invokes the function linked with the DynamoDB stream, with any change in the record. An S3 event notification for a new file upload, or update to an existing file can trigger a Lambda function. An event can be a CloudWatch scheduler using a cron job and so on.